So the definition of non-deterministic finite automata is here. And then in this mistake I have done, I forgot to initial. Let me write in the PDF dashboard. Oops, wait, it's here. I was checking for this open file. This one, right? Oh. Okay, this part, right? Wait. It's, I don't know. My system is not responding quickly today. So this one, right? I've used highlighter. This one, right? Please go back in your textbook. This summation will include epsilon. Okay. This summation will include epsilon. I'll be, while explaining the example, I'll talk about that one. So don't worry about that. So this one, right? Summation union epsilon will be there in your textbook. Okay. And this is known as power set. This is known as power set. And then I've mentioned the page number in your textbook. So this one you have to read it. This is about the set. Power set and all I'm going to explain. So read by yourself. So this mathematical definition of non-deterministic finite automata, right? Let it be like this. Let me take one example straightly. The main how to differentiate between the FA and FA. This particular non-determinate automata, right? In some book, you can see referring them as MDFA. In some textbook, they might be referred as an FA. Both are correct. It's up to you. But where is the main transition means? This transition function will differentiate between the DFA and the NFA. Okay. So let me try to take examples straightly so that we could begin. And next slide, it's about non-determinism. Like why this particular machine is being called as non-deterministic. In the previous part, why the machine has been termed as deterministic. Let me take the example and then instead of explaining this line by line, right? Let me just take an example and then explain it straightly. And then next, a few points about DFA and DFA and this and all. Once we start solving the example, we'll start with that one. So let me start the example. For example, also I need to use one. I used to open one. This one. Scribble this thing that also today I don't know it's responding what's happening I don't know, so please bear me just for 1 or 2 seconds and then let me start that one and let me take the example and then I'll be explaining here. Okay, design NFA or NDFA for given language L. Language is represented by L. It's equal to all strings ends with 0, where summation is equal to 0, 1. Okay. I haven't explained the mathematical definition of NF or MDFA. So with this example, I will be explaining that one. With this example, I'll be explaining this NFA or MDFA. Now, in the previous class for designing the DFA, right, we have to understand the language. While designing the DFA, to understand the language first. So this language, right, I need to understand that one. So this language L, it's a collection of string which ends with 0, 1. But what are the combination of strings we are going to see means it's going to be a combination of 0, 1, but it has to end with 0, 1. So it means what? 0, 1 will be accepted. Okay, 0, 1 will be accepted. And then 1, 1, 1, 1, 1, 1, 0, 1 will be accepted. then 0, 0, 0, 0, 0, 0, 0, 0, 1 will be accepted because it ends with 0, 1. It ends with 0, 1. And then 1, 0, 1, 0, 1, 0, 0, 1 will be accepted because it ends with 0, 1. So this language is a collection of a string which ends with 0, 1. Now let me start the designing part. Similar to DFA, in the case of NFA or NDFA, we need to have an initial state. We need to have an initial state. So let me represent this initial state by this Q naught. How to indicate this initial state means with this arrow. Okay. Now, again, how I have designed the DFA, likewise, from this collection of string, I need to consider a string of least length. Least length means this one. So, how to indicate the acceptance of a string means it's the transition, the final transition state is the final state. Then we can conclude that the string is being accepted by that machine. Okay, so 0, 1 is being accepted. Now, what about this maximum? And in this case, how many number of ones I have? 1, 2, 3, 4, 5, 6. 6 number of ones. Sometimes it may be like 1, 1, 1, 1, 1, 1, 1, 1, 1, n number of 1. And then if ending with 0, 1, that will be also accepted because it ends with 0, 1. Hence, what I need to do is I'm going to provide a self loop with level 1. So any number of 1, either maybe n number of 1, n minus 1, n minus 1 number of 1, or single 1, whatever may be, if it ends with 0, 1, it will be accepted by this machine. Now, let's talk about this number of zeros here. 1, 2, 3, 4, 5. This is 5 number of zeros. What about n number of zeros and then it ends with 0, 1? That will be accepted. Hence, let me provide here in this self loop another level of 0, 1. Okay. So, and then what about 1, 0, 1, 0? Yes, this is self loop. You can have many number of 1, 0, 1, 0 combination here. Doesn't matter. Doesn't matter. We need not specify such kind of condition separately because our specific, in the question itself, the specific condition is all the strings, whichever having the combination of 0, 1, but it ends with 0, 1, then you're going to accept it. Okay. This is the required NFA. This is the required NFA. Now, I need to explain this one further. But before I explain this one, right? Let me define the the mathematical definition of this particular machine. So let me call this figure number 1. Figure number 1, NFA of the given language L. NFA of the given language. Not write any shortcut in exams and all, right? Mine, I'm the faculty, so I'm using the short term here, language L. Okay. Now, let me describe the mathematical definition. Let me represent the machine as M, and then this machine has to be defined by this almost same summation, then Q naught, then this, almost same. Okay. Now, this is equal to how many states? Q naught, comma, Q1, comma, Q2. Summation, it's already provided, but still you need to write because this is the mathematical definition of this NFA. Q naught, I have considered Q naught as the initial state for this particular machine diagram. So let me just write Q naught here. And then transition, I'll be writing, defining it separately. And then how many final state? Only a single one. So let me write like this. And then where transition function are delta Q naught, comma 0, Q naught. Okay. Delta Q naught, comma 1 is equal to Q naught. Delta Q. Okay, okay. You might be confusing. Let me put an underline here. Not here. Not here. Let me put an underline here. An underline here. Delta Q naught comma 0. Q1. Let me just underline this too. Q2. Okay. Now, I know you guys might be confused a bit. Let me clarify within a second, okay? So don't worry. Do not raise any queries right now. Let me just complete it. Now, see here, how to check the acceptability. How to check the acceptability of a string in an NFA or NDFA. How to check? So let me just consider one string. W1 is equal to. Usually, string is represented by small letter X, Y, Z, W, and all the alphabetical small letter formats are being utilized for representing a string. That's why, in general, in textbook you can find W as representing always the string. That's why I've considered W as the for representing a string. So let me consider 0001. I'm going to check whether W1 is being accepted by this machine given in figure 1. Okay, let me just check it. 0, 0, 0, 1. So as per the diagram, the initial state is Q naught. As per the diagram, the initial state is Q naught. So let me write Q naught here. Now, currently at state Q naught, if the input symbol is 0, one self loop is here. Another one is it will perform the transition from Q0 to Q1. There are two options. Okay, there are two parts of performing the transition from either from Q0 to Q0 itself or else from Q0 to Q1 if the input symbol is 0. Okay, I'm repeating again, the current state is Q naught. If the symbol is 0, there are two possibilities. There are two possibilities. I've already underlined it here. First one is either it will stay in the same state Q naught, and second one is it will perform the transition from Q naught to Q1. Okay. So in this case, right, we cannot consider that no need for this Q naught. We have to move to Q1. You should not do like that. Okay. What the possibilities you need to mention here. So I have to mention that one. So let me just write Q naught. It's up to you. If you want to write Q naught here or Q1 here, it's up to your choice. Okay. Now two parts are being generated here. Next one is Q naught. Again, two parts will be generated. So let me just write Q1. Same here, two parts will be generated. Okay. Now, each part, right, you cannot leave it as it is. You have to complete it. You have to complete it. So let me complete the first part first. So Q naught 1 from the diagram Q naught with 1 means it will remains in the Q naught itself. So let me write Q naught. Next, let me try to complete this. So in this one, right, what is the value? I guess I have to. So in this one, right, what is the next term? 0. Let me write here. So Q1 from the diagram, Q1 0 means no part is available. Q1 0 means no part is available. No part is available. No part is available. So how to check that one means phi. Phi is indicating that no part is being provided at this Q1 if the input symbol is what? 0. Okay. Same thing will be here. Why I'm getting this 0 means the string is 0001. The string is 0001. That's why I have to check for all this 0001. Now same thing will happen for this. Same thing will happen for this Q105. Q105. Uh-huh. Next one. Okay. Here one doubt is there. One doubt or one mistake. This 0001, right? This 0001 is being designed. It's being designed to accept it. Okay, okay, one mistake I have done here. One mistake I have done here. Q naught. One mistake I have done here. What I need to do here is, let me just redraw this diagram here and then let me check this here again. Okay, it's quite confusing for me, or else shall I rough this part? You guys doesn't have any issue, right? Or else I'll do one thing. This part, right? Let me do it in the second page. This part totally I'll do it in the second page. So do not copy anything. Instead, I need to combine these two underlined part. How to combine means instead of writing these two separately, you have to write like this. Oh, sorry, I'm not comfortable. Okay, I'm still facing some problem. Oh, okay. Sorry, okay, I'm not handy with this thing. So let me just combine it. Q naught comma 0 is equal to Q naught comma Q1. So instead of writing separately, you have to write like this. Okay. And then for checking the string, let me start in the next page. It's quite confusing for me. Okay. Instead of, let me just draw the diagram in a very smaller version. 0 comma 1, 0, Q1, 1, Q2. Now let me start for the Q1. What was that? 0001. So this one 0, this one 0, this one 0, this one 1. And then Q naught, we have two options. Q naught, Q1, 0. This is again Q naught, Q1, and then okay. So multiple part will be available here. So let me start. As per the aim of this machine, right? 0001 has to be accepted. As per the when I first started designing this machine, right? My target is to accept this string. Why? Because it ends with 01. Because it ends with 01. Because it ends with 01. So this has to be accepted. But when I check this one, right, Q naught when the symbol is 0, either it will perform the transition from Q naught to Q naught itself or else from Q naught to Q1. Again, the same thing. Q naught, and then if it is 0, either Q naught or Q1. Again, the same goes here like this. And next one is Q naught. Next one is Q naught 0, then phi. Phi means no path is exists. No path exists for this 0. Currently at state Q1, but for the state for the input symbol 0, there is no path. Hence, no path is being represented by pi. No path is being represented by phi. Again, same here 0. No path being represented by phi. Again, Q naught 1 means Q naught 1 means Q naught itself. This does not belong to final state and this is not accepted by this machine. But my target is to accept this string, but it's not accepting that one. So where is my error means I'm making an error here. I have to insert 0 here. Okay. Or else, when I insert a 0 here, we'll check. Let me just rub it. Uh, just let me just rub it. Let me just rub it. Now, let's see whether my machine is going to accept this one or not. Okay. Now, in here, this is before inserting 0 here. After inserting 0 here, I need to clear this part. After inserting this, I've already told if you want to enter, once I start the class, I won't allow. Now, let's see. After inserting this self loop 0 here, I'm going to check whether this is going to be accepted or not. So Q naught 0, obviously no need to explain this one. So let me continue. This does not belong to this. Now what about this part? Q1 0, it will be Q1. Okay. State is Q1, input symbol is 0, it will be Q1. Now next, how many zeros? 3 zeros. Next again 0, same it will be Q1. Next one is 1. Next one is 1. So if it is 1, if it is 1, then it is Q2. Now this Q2 belongs to final state. Hence 00001 is being accepted by this machine. Now let me number this machine as figure number 1. Okay. Now again the same thing will happen. Same thing will happen because same, right? So this will belongs to F, this will belongs to F. At the end, this will be Q2, Q2, Q2. Now, in the case of NFA, right, how to check the acceptability of a particular string means Is it audible? Is it audible? Because I'm facing some
Yes,
internet issue. Okay.
yes, ma'am. Yes.
Yes, ma'am.
Okay, okay, fine, thank you. I'm facing some internet issue, okay? That's why it keeps on turning. Now see here, while designing this figure, I have considered myself a beginner. Now let me, in the last semester also I have told you should not increase the number of IC and all while designing a circuit. You have to design an efficient circuit. Now let me just redesign this machine. Q naught. Oh, Q naught. I'm just seeking some opinion, okay? I'll just do it. Okay. Instead of checking the acceptability like this, let me just give you a hint about this machine. This is wrong. Why means our target is to design an NFA which will accept the string ends with 01. Okay, string ends with 01. But in this particular machine, it is accepted single one. It is accepting single one. Hence, this machine is wrong. Okay. Now again, another case, instead of, here I have modified a self loop of 0, a self loop of 0. And then in this figure number 3, I have provided a self loop of 0, comma 1. Here, I have provided a self loop of 0 here. In this machine, I have provided a self loop of 0, comma 1. So let's see something. Let's see something. Let me have 0, 0, 0, 0, 1, 1, 1, 1, 1, 1. Why? Because let me just 1, 2, 3, 4, 1. Yes, this could be generated from this machine because currently at Q naught, any number of zeros you can generate. Suppose 3 numbers of zeros being generated here, and then fourth one in here, and then number of ones, how many ones? 4 ones. 4 ones here, and the last ones here. Okay, so when I check the acceptability, let me just do it. Q naught, this is Q naught, this is Q naught, this is Q naught, and then I'm just removing the multi-part. Only I'm choosing the acceptability part alone. And then this one Q1, this one Q1, this one Q1, this one Q1, this one Q2. So this is being accepted. But my target is the machine should accept the string ends with 0, 1. But this machine is accepting the string which ends with number of 1 series. So this is also wrong. Okay. So you need to practice a lot. It's not that I have to design like this is same, this is the solid, this is the final machine. No. After practicing only, I can able to analyze it whether this one is correct, this one is wrong. So my advice is do practice a lot, okay? And then, so 2, 3 options are wrong. So this is the only machines I can think of right now. Now, after designing this machine, right, let me give you a hint, a difference between a DFA and an NFA. DFA, no need to repeat it because last class I've already discussed it. This is one NFA. Let me give you a differences between DFA and NFA. Compared to DFA, NFA is easy to design. Okay. Compared to DFA, in the case of NFA, you need not mention all the parts for the given symbol. In our example, the given symbols are 0, 1. In the state Q0, I have provided the part for both the symbols 0, 1. In the state Q1, I have provided the part for both the symbols 0, 1. In the state Q2, I have not provided the path for 0, 1. Okay, this is the difference between DFA and NFA. In the case of DFA, you have to provide the path for all the possible symbols 0, 1 for all the states in this machine DFA. But in the case of NFA, you need not provide the path, all the paths from the given 0, 1. Okay. And one similarity is there between DFA and NFA. Both are comes under the category finite automata. Finite automata, you can have a single initial state, but you can have more than one final state. And then the main difference between DFA and NFA, right, it lies in the transition function like that I have already mentioned. How means in the case of DFA and NFA, I don't know whether I have stated or not. Okay. This is not possible in the case of DFA. In the case of DFA, see here, in state Q naught, in the case of NFA, for a single input, you can have more than one possibility of transition from one state to other. I'm repeating it again. For a given state, you can have the possibility of performing the transition from one state to another in the case of NFA. But such things could not be happening in the case of DFA. So these are the differences between NFA and DFA. Okay. So some what to say points between deterministic and non-deterministic. You can Google it. You can find many differences are there. And then one more thing, I haven't mentioned anything about this epsilon. Okay. I haven't mentioned anything about this epsilon. This is going to be discussed as a separate class. So today I'm not going to mention. This is a huge, not huge. It will occupy one single class. That's why I haven't mentioned anything about this epsilon transition. Okay. Do not get confused. And my advice is go back while reading the textbook, whatever I have taught in this class, that alone you just select it and do the studies. Other than that, don't do it. It will get confused. Some might say that this paper is very complex. No. Once you start understanding step by step, it's not complex at all. Okay, so today I haven't mentioned this epsilon transition, so do not read anything about this epsilon transition from your textbook today. And then one more thing, in this particular transition function definition of the non-deterministic finite automata, I have also included that summation union epsilon. But I haven't mentioned anything about this epsilon. This one also you can skip it. But power state you have to do the studies by yourself. Now this IDs and all, wait. For today, let me take another example of NFA again. Let me take another example of NFA. Let's design an NFA of the given language. L is equal to all strings over the summation is equal to A, B that have my handwriting is the worst handwriting you people might have seen, so please bear with me. At least two consecutive A's or B's. Okay, now I'm going to design an NFA for this language L. So the same thing, I'm going to repeat it again. L I need to understand first. L is going to be a combination of A's and B's, but the condition is you need to have either AA or BB in between. Okay, not in between. You need to have it, whether in the initial point, whether in the ending point, or maybe in between. The language should have AA or BB, at least two consecutive. Okay, so such condition you need to find it out first. So as per this condition, your language, I mean, your machine should accept either AA or BB, and then A, this has to be accepted. A, B, then B, because it consists of A, then B, A should be accepted because it got A somewhere, and then B, this has to be accepted because somewhere it consists of B. Okay, this is the language. And then now, as usual, I'm going to start the designing the NFA with the initial state. So let me consider an initial state as Q1. Guys, one more tips here. Somewhere I find one of your senior used to use initial state as Q5 and other state as Q0, Q1, Q2, like that. Even though the rules permit you, plus please don't do that. If you're going to consider, if you're going to assume initial state is Q1, then other state has suffix has to be greater than that one. Okay, please follow that one. So initial state. And then one more thing, there's a term including here, or. Okay, or either your string consists of double A or BB. This has to be accepted, right? And then many combinations are there. I mean, A B combination or whatever. So many combinations are there. Many combination, infinite number of combination you can generate from itself. Look, A comma B. So I have gone here. Now, next one is you will get confused, so I'll not do like this. Okay. So first, let me draw AA. Q1, Q2, Q3. So as per this diagram, it will accept double A. It will accept. It will accept. What else? No, it will accept any string. Any string with combination of AB, but ending with AA. But what about this one? Starting with AA and then any combination of AB. For that, I need to insert A comma B here. Okay. So A part completed. A part completed. This completed, then completed. Okay. I'm considering this tree string itself, any number of combination of such type will be accepted by this machine. So next one is or, right? Or then B, next state. See how your machine has to look depends on you. So while drawing, you please prefer your own design. Q5, B. So again, BB is being accepted for this one, and then any combination ending with BB is being accepted by this one. What about the beginning with BB and then AB combination? For that, I need to insert A comma B here. Okay. So let me check the acceptability. Acceptability, let me just consider A, B, then AA. Okay. Triple A. This has to be accepted because double A is there. So let me just check the initial state. Q1, A, two possibilities are there. One is Q1 itself Another one is Q2. This is A. So from Q1, right? B. Q1B, how many options? Q1 itself, then Q4. Then next one is A. Q1A, Q1 itself, then Q2. Next, Q1, A completed, B completed, A, then B. Q1B, Q1 itself, then Q4. Okay. Next one is A. Q1A, either Q1 itself or else Q2. So A completed. Next one is A. Q1 itself, then Q2. This is A. So next A is completed. So next A, oh, Q1A, this is Q1 or else Q2A. Okay. So again, all these parts needs to be completed. All these parts need to be completed. So let me just complete one of the part, which is being. I mean, which I'm very much sure that it's going to be the final part. That alone, I'll just do it. Q3. So Q3 belongs to final state. One of the multi-part ends with final state. Then you can conclude that this string is being accepted by this machine. The same thing here, you need to define the 5 tuples 1, that this one, this, then initial state, then transition function, then what else? And these things you need to define. So I'll not, extend the class further. So please go back in your textbook, wherever you find the examples related to NFA or MDFA, please try out by yourself. Okay. And just wait a second, please. Okay, fine. That's the end of the today's class. So please, tomorrow I'll be having class by 11 a.m. And tomorrow I'll be taking up another topic. Before that, my request is please try to practice many number of DFA examples and NFA examples in the textbook. In your textbook, all the examples are being provided scattered way. Select those examples which is related to NFA and DFA, and please practice by yourself. So tomorrow I'll be taking a new topic. So before that, practice well. Okay, thank you.